Hello everyone and welcome to the second video of this series. This is C++ engine programming with the nCine. In this video we're going to talk about the application lifecycle, and we'll start with the main function. Main function is the entry point of every C and C++ program, and this is where also the engine starts. The engine starts with the start method of the PC application class, which will take a pointer to a function in order to create an app event under the class, but we will see this later. The application start method will initialize the engine and then just run. Run is really just calling the step method again and again until a certain condition is true. In this case, if we want to quit the application. If we want to quit the application, then it will just call the shutdown common method, which will shut down everything. The app event handler class, it's an interface class that you can derive to override some methods. Those methods are actually callback that the engine will call in order to execute the application code. There are many different methods that the engine will call at specific times. For example, when it starts up, when it shuts down, when the engine is suspended or resumed, or at every frame start. The first method is the onPreInit, and it will pass you a reference to an object of the app configuration class. This is a structure containing some fields that you can change in order to setting up the engine. You can decide the logging level, you can decide to have a log file, you can choose a screen resolution, or if you want the application to be full screen or not. You can choose a window title and icon. There are some rendering settings that you can change, and there are some subsystems which are optional, and you can decide if you want to initialize them or not. So now the application initializes. There are some timers which starts to keep track of how much time has passed. Then we register the logger. That's the first service that we register so that we have the logging capability in place as soon as possible. And then the engine calls the first function in your app event handler class, the onPreInit. After that, we have enough information to construct a graphics device and an input manager. Then we proceed registering the remaining services such as the audio device or the thread pool or graphic capabilities object, which will query OpenGL in order to see on which hardware is running and what are the capabilities that it can access. And then we go on with the initialization. We initialize IMGUI and Nuclear if they are enabled, and then we will construct the initial rendering or scene graph objects, like for example the rendering resources, the render queue, or the root scene node. This is the first scene node that you can use to add your child scene node and create your scene. And then it's time to call the onInit in your app event handler. So now it's time for your application to create, initialize its own resources. And now we just execute an application step again and again. We collect the input events from the backend, such as GLFW or STL2, depending on what you have to choose. And then we clear the screen. We call here the onFrame start of your event handler. It's here where your application will do all its frame processing. Now we can update, visit and draw the scene graph. You have added your own sprite, for example, in the onInit method, and then you have moved them the onFrame start. Now it's time to visit this new scene graph, update all the transformations and render it. Then it's time to update the audio players, their loop state, or if you're streaming music, you want to update the streaming buffers. At the end, we just swap the rendering buffers. When we want to shut down the application, the first thing that we do is calling the onShutdown in the app event handler, so you can free your own resources. Then it's time to free the resources of the engine, like all the singletons, all the smart pointers. We can then dispose the rendering resources. And then as last thing, we unregister the logger service so that we have the logging capabilities to the very end. But now it's time to get our hands dirty and see the code. So here it is, the main function. As you can see, it's a bit longer than the one that I've shown you before in the slide, but that's because it contains support for different platforms and different backends. Actually, what it is executing in this particular configuration is just the line that I've shown you before, this start method. And we can put a breakpoint here and see what happens. Here we are in the main function. As you can see from this stack trace, there are no other functions. That's really the first function which is executed. That's the entry point of our application. And we are now entering into the start method. Start method is just init, run and shut down as I shown you before, plus some other things which are related to other platforms. So now we are ready to enter into the init function. The first line is just a zone declaration for Tracy. We will look at Tracy later on in another video, I'm sure. And then we start the timer. After the timer, we register the logger. That's the thing that we want to initialize as soon as possible. Then we store a pointer of the app event handler so that we can call the function later on. And then it's time to call the on pre-init with the app configuration. So now we are into our application, which is in this case is not doing much, but it has a chance to change the configuration. And then we are back. Now we have all the settings in order to initialize the logger, for example. Now we know what kind of logging level the user wants. And we can open a log file. We also have all the information to initialize the graphics. So we put together some of this information into different classes, for example for the display mode or the window mode, and then it's time to create a graphics device. Here you can see that we have 3 different versions, one for each desktop backend. We have compiled the engine with GLFW, so we are going to create the GLFW specific version of a graphics device, and then the input manager as well. Then we set the window title and the window icon, and we stop the timer. We have different timers here. We have just stored the pre-init timing. Then it's time for the init common method, which is in common throughout the whole supported platform. So Android as well will execute this method. We start another timer here, and then we register the other services, like audio, threads, or the graphic capabilities class. As you can see, you can, for example, either completely disable audio from being compiled, or you can have it compiled but then at runtime decide if you want it audio or not. And this is coming from the application configuration class. We swap the frame so that in a tracing application like API trace, we will have some OpenGL calls that are just related with the initialization of the engine, and we will keep a regular frame separated from those. Then it's time for the frame timer to be initialized. The frame timer contains the number of frames that have been rendered up to now, or how much time a frame takes. If we have ImGUI or Nuclear, that's the time to initialize the drawing classes. The scene graph as well, it's something that you can disable at runtime. If we have the scene graph, then we will create the render queue or the root node of the scene graph. Then the PCG random generator will be initialized, and then we stop the init common timer. Now the engine is basically initialized, and we can call the initialize function of the application. That's what the rotate zoom example is doing, just creating some texture and some nodes. We also take how much time the application initialization method has taken. The user might have added some fonts for ImGUI or Nuclear, some custom fonts in the onInitialization function, and then now it's time to build those fonts. We swap again the frame, and then we are ready to run. As you can see, it's really just a while loop with a step function. Let's see what the steps function is doing. We are counting the frames, clearing the screen, adding a new ImGUI frame, and then here we call the onFrame start of the app event handler. That's where your application will do all the frame related processing. That's what the RotaZoom application is doing every frame. If we have the scene graph, it's now time to update, visit and draw it. We then update the audio players, we end an ImGUI frame, and we swap the buffers. The frame is completed now. But let's see what happens when the application shuts down. Let's put a breakpoint here. The first thing is the onShutdown method of the app event handler. So if you have any code disposing resources, that's the time to clear all the memory. In this case, the RotaZoom example is doing everything with smart pointers, so it hasn't overridden the onShutdown method. Now it's time to reset all those pointers to free up memory. And then we unregister all the services. As you can see here, the logger is the last service to be unregistered, and that's because we want to give a chance to the application to log up to the end. We are back in the start method. Shutdown command has finished, so we are ready to return. And we return from the main as well. The application ends. I hope you have enjoyed this video. Let me know everything in the comments and see you for another video in this series.